So this video is Integrated 3, Chapter 10, D-Day, number 1. So this is going to be on sequences and series and the binomial probabilities and binomial expansion and theorem. So on this first one, they want us to find the sum of this geometric series, okay? And we are going to be summing from 1 to 10, the first 10 terms. So the formula for the sum is S sub n is equal to the first term, a sub 1, times the quantity 1 minus r, where r is what you're timesing by, to the power n, where n is how many terms we're adding, all over 1 minus r. That is the formula. Now, to find a sub 1, we can put 1 into our equation. So we're going to have 200 times 0.8 to the 1 minus 1. So that is just going to be 0.8 to the power 0. So when I do that, I am just going to end up getting 200. So when this is raised to the I minus 1 or n minus 1, x minus 1, whatever variable minus 1, this is going to end up being your first term, but you can always plug 1 in there to verify if you're not sure. So in this case, I am going to be finding S sub 10. So S sub 10 is going to be my first term, which is 200 times 1 minus my r, and my r is that 0.8, and this is going to be raised to the power 10 all over 1 minus 0.8. Now, when I'm doing this, if I'm doing this not using a fraction, I definitely want parentheses around the bottom, okay? So if I put this into my calculator, I'm just going to get my division sign first, okay? I'm going to go 200 times 1 minus 0.8 raised to the power 10. Then on the bottom, I'm going to have, and I don't need parentheses if I'm doing it in this fraction form, 1 minus 0.8, or you could just put 0.2. And there's my answer. So this is going to be about 892 point, let's say 63. Now on number 2, this one here, we are also finding the sum of this sequence, okay? And we need to figure out what we're doing every single time. So looking at this, the numerator in each situation is staying a 3. The denominators change from a 4 to a 12 to a 36. So it looks like I'm multiplying by 1/3 because the bottom is being times by 3, but actually by a negative 1/3 because I have alternating signs. I have a negative, then I have a positive. So I'm multiplying by a negative 1/3. So in this case, this one is asking me for an infinite sum because this is going dot, dot, dot. So when I'm dealing with an infinite sum, the formula for an infinite sum for geometric, S is equal to A1 over 1 minus R. But the trick is your R in absolute value has to be between 0 and 1. And in this case, it is. It's a negative 1/3. And my first term is that 3/4. That's my A1. So when I'm trying to find S, it's going to be 3/4 over 1 minus a negative 1/3. So that is going to be 3/4 over 1 and 1/3, but I'm actually going to think of it instead because I'm going to be adding it because it's minus an a, which becomes plus a positive. But it's really like a 3/3 plus a 1/3, so it's going to be a 4/3. Now, when I'm doing this, I can really think of this as 3/4 times the reciprocal Okay, instead of dividing by 4/3, I'm multiplying by the reciprocal, which is going to be, whoops, I'm still in highlight, which is going to be the 3/4 is reciprocal of 4/3. So I am going to get 9/16 as my answer. Now I can also put this into my calculator. And so I could do 3/4. Here, I'm going to do it like this. I am going to clear. I'm going to get my fraction bar first. Then I'm going to go 3/4 in my numerator. And on bottom, it's going to be 1 minus. And I'm going to go parenthesis a -1/3. And I see I get 0.5625. If I hit this fraction here, you can see I got 9/16. So you can also put it into your calculator. On number 3, find the sum algebraically of this. Now this one is arithmetic. This is an arithmetic sequence here. And we also have to be careful because we're not starting at the first term, we're starting at the 4th through the 23rd, which really means when I'm doing this math and I'm adding this up, I'm going to have 23 minus 4, and then don't forget to add 1 because we got to count that 4. That's also part of this. And when I do that, 23 minus 4 is going to be a 19 plus 1 is 20 terms. Okay. And I'm going to be using the formula S sub n is equal to n times the quantity A1 plus A sub n all over 2. Now, and when I say A1, I really shouldn't say A1 because in this case, it's really going to be A sub 4 because that's the first term. And when I say A sub n, it's going to be A sub 23 because that's going to be the last term. So I need to find my first term, which in this case is going to be my 4th term. So I'm going to go 15 minus 3 times 4. That's 15 minus 12, which is 3. Then A sub 23, sorry, put 24. A sub 23 is going to be 15 minus 3 times 23. And let's see, 15 minus 3 times 23 is a -54, a -54. So when I substitute in here, I'm going to find 20 terms is what I'm adding. So I've got 20 times A sub 4, which is 3. And A sub 23 is I'd be adding a -54, so minus 54, all over 2. So really this is going to be 10 times a -51. So it's going to be a -510. That is my sum. On number 4, given the series here, we want to write the series using summation notation. So when I am doing this, I'm not subtracting because subtracting from here to here is definitely going to be different from subtracting from here to here. So I'm thinking that we're dividing. So I'm going to take 592 divided by 2,368. I'm going to do the second divided by the first to see what I times the first one by to get the second. So when I do that, 592 divided by 2,368, and I got 0.25. I'm timesing by 0.25 or 1/4. So when we're doing this, I am going to have, well, it doesn't say what I'm adding up to. So I'm going to start with n equal 1, let's say to infinity, because it doesn't give us any particular endpoint. And I'm going to write my equation, and my equation is parenthesis, I'm starting with 2,368, which is my first term, not my zero term. I'm adding, sorry, not adding. I'm timesing by, let me do it this way. I'm gonna put a bracket here. I'm timesing by 0.25 or 1/4 to the power n minus 1. And that is going to be our equation. And the reason that this is an n minus 1 is because this is my first term, not my zero term. Okay, on number 5, I am subtracting 6. So if we're writing this one, a couple things I know. I need to start with my first term. I need to figure out what term this one is. This is not dot, dot, dot. It ends at a particular value. So I'm going to have to figure out what that is. Now I'm going to write an equation. And that equation for a sub n is going to be -5. And I'm minusing 6 n minus 1 times. Now I'm going to put in a -47 here. And I'm going to work this out. So I'm going to be adding 5, which gives me a -42. I'm going to be dividing by a -6, which gives me a 7. And then I add 1. So that term here is my 8th term. So I am going to be going from my first term to my 8th term. You need to have a value up there. And then I'm going to write my equation. My equation was -5 minus 6 times n minus 1. That's your summation notation. On number 6, find the sum of the first 42 terms. So looking at this, it looks like I'm adding 17. So if I was to figure out an equation for this, I am going to have 43. I'm adding 17 n minus 1 time. I need to know to find the sum, my first term, which I know, but I also need to find my 42nd term. So I'm going to find a sub 42. That is going to be 43 plus 17 times 42 minus 1. And when I put that in my calculator, I'm going to get 40. Oops. Let me hit return. Okay. So I'm going to get 43 plus 17 times basically 41. And so I get 740. That is going to be my 42nd term. So when I'm doing this, S sub 42 is going to be equal to 42 times my first term, which is 43, plus my 42nd term, which is 740, divided by 2. So I'm going to have 42 times the quantity, 43 plus 740 divided by 2. So I end up getting 16,443 as our answer. On 7, find the sum. So in this case, they're telling us to kind of break this up into baby steps. First thing I'm noticing, it looks like we are, let's see, subtracting. See, if I take 1192, whoops, let me get out of that. Let me just clear all. Okay, so if I take 1192 and I minus 1181, I get 11. So it looks like I'm minusing 11. So when they ask us to write an expression for a sub n, or for the nth term, a sub n is equal to 1,192. And we are minusing 11 n minus 1 times because this is our first term. How many terms are in this series? So what I'm going to do is I'm going to take this 389, put it in for my a sub n, and figure out what n is. So I am going to be subtracting 389 minus 1192, and I end up with a negative 803 is equal to a negative 11 times n minus 1. So I am going to take that answer, and I'm going to divide that answer by negative 11, and I get 73 is equal to n minus 1. So n is going to be 74. It's my 74th term. Then they want us to find the sum of the series. Okay, so I'm going to find S sub 74 because there's 74 terms. So I'm going to go 74 times my first term, which is 1192, plus my last term, which is 389, divided by 2. So I'm going to have 74 times the quantity 1192 plus, let me go back, plus 389 over 2. And we end up getting 58,497 as our answer. On number 8. So we have the 10th term. So I'm going to write an equation starting with the 10th term. And they're telling us that this is arithmetic. So 282. I'm adding some d. Since this is my 10th term, this is going to be an n minus 10 because this one here is our 10th term. So now I'm going to put in the second value here, 414 in for my a sub n. Let me write that better. So 414. So I'm going to have 282 plus d, not sure what d is. I know that this is my 15th term, so 15 minus 10. So 414 is equal to 282 plus 5d. I am going to subtract, so 414 minus 282. I end up with 132 is equal to 5d. I am going to divide by 5. And when I take 132 divided by 5, I get 26.4 is what we're adding. So our equation is going to be a sub n is equal to 282 plus 26.4 times n minus 10. And you can leave it like this. On number 9, so when we're dealing with this, we've got a triangle, okay? So let me just insert a triangle. Okay, and I'm just going to adjust it. It's not like a any special triangle. Okay. So in this triangle, let's say this is 16 because that looks like the longer side. Let's say this is 11.4. And let's say that this is 8.7. So my 16 is my little b, which means this angle across from it's going to be big B. 11.4 is my A, so this angle across from it's going to be big A. And that means that this is going to be C. And we want to find this angle right here. So if I'm going to find this angle, I am going to use the law of cosines. So to find that angle, the formula I'm going to use is the following. So the formula, let me write it here. If I want to find angle A, I'm going to take cosine of angle A is equal to B squared plus C squared minus A squared all over 2BC. So when I want to find cosine of A, I am going to be taking 16 squared plus 11.4 squared, and I'm going to minus 8.7 squared. And that's going to be over 2 times 16 times 11.4. And so when I put that into my calculator, and I make sure that my calculator is in degrees, okay? So I'm going to have 16 squared plus 11.4 squared minus 8.7 squared all over 2 times 16 times 11.4. And as a fraction, this is what I get. So let me just keep it kind of exact. 1633 over 1920. I want the angle, not the cosine value. That's my cosine value there. So I'm going to do cosine inverse of 1633 over 1920. So I'm going to do cosine to the negative first. Let's see. Oh, okay, here it is. Okay, cosine to the negative first of 1633 divided by 1920, and I end up with about 31.73 degrees. That is the angle. On 10, we want to find from 0 to 2 pi, including 2 pi, where our sine, the angle where our sine is equal to -3 root 2. So first off, my sine is negative in quadrant 2. And sorry, my sine is not negative there. I apologize. Sine is my y. So it's negative in quadrant 3 and quadrant 4. Okay, this is where it is negative. And my sine is my y, so my √3/2 is long. So I want short long, which is going to put me right here, and short long, which is going to put me right there. So these are thirds. So this is going to be 4 pi thirds. And this one's going to be 5 pi thirds. And those are our two answers. Okay, on number 11, we're going to solve all of these roots. So when I do my P over Q, I basically want factors of 21 on top. So that's going to be positive -1, 3, 7, and 21. And on bottom, it's just going to be 1, positive and -1. So I basically have positive -1, positive -3, positive -7, and positive -21. So I'm going to do my synthetic division. I have a 1, a -5, a -17, and a 21. Let's say I try 1. I bring down my first number 1. And when I'm doing this, 1 times 1 is 1. I add it, I get a -4. -4 times 1 is -4. I add it, I get a -21. -21 times 1 is -21. Add it, I get a 0. So I know one answer. One answer is x equal 1. I'm now going to take this depressed polynomial. So this depressed polynomial, and I'm going to do a new synthetic division. So, and actually I don't even need to do synthetic division because this is going to be a degree 2. So this is going to be x squared minus 4x minus 21. And we want to know what makes that 0. So if I factor this, what multiplies to -21 and adds to -4? Well, that is going to be a -7 and a +3. So I get x equals 7 and I get x equal -3. So 7 and -3. These are my solutions. On number 12, we want to write, they're asking us to write a sine graph for this. So if I'm looking at this, let me just kind of jot down my highs and lows. So I have a high up here at 20, a low at -10. So if we average 20 plus a -10, I get 10. Divided by 2, I get 5. So when I'm doing this, this is going to be at height of y equal 5. So my k is going to be 5. Now, if this is at 5, I'm going up or I'm going down, basically 15. So that's going to be my A. I'm going to start here, which is going to be a, let's see, 1, 2, 3, 4, 5. So this is going to be at 3, 5. Okay, so this point here is at 3, 5. So when we write our equation, it's going to be y equal our A, which is 15, because I'm going to be basically going from here to here. Sine of, and this is where I need my B. So if I am looking at this, and I'm trying to see all my zeros, okay, I'm going from here to here, from basically 0, 1, 2, 3. So that's 3. Over here, that's 15. So 15 minus 3 is going to be 12. Okay. And you see 12 is my point that's going to be like a low. Okay. So when I'm doing this, my B, and I should say this, the period is equal to 12 pi over B. Our period is 12, so this is going to be 12 equals 2 pi over B. I'm going to times both sides by B. I'm going to divide by 12, and I get B is equal to 2 pi over 12, or pi 6. That's going to be my B. So my equation is going to be y equal 15 times quantity times sine, and in front of my x, I'm going to have a pi 6. That's my B. I'm starting over here at 3, so this is going to be x minus 3, and then plus 5. That's our equation. On February 10th, 1990, high tide in Boston was at midnight. Okay, so let me highlight that. So high tide was at midnight. The water level at high tide was 9.9 feet. Later at low tide, okay, low tide, it was at 0.1 feet. Assuming the next high tide, okay, the next high tide is exactly 12 hours later, and that the height of the water is given by a sine or cosine curve, find a formula for the water level in Boston as a function of time. So for this, let me kind of sketch what's happening here. Okay, so our high tide is going to be at 9.9 feet. Okay, let me just zoom in here. Let me get this big screen here. Okay, so move this a little bit. Okay, so our high tide is at 9.9 feet. Our low tide is at 0.1 feet. Now, halfway between that, if I take 9.9, I add it with 0.1 and divide by 2, I get basically 10 divided by 2, which is going to be 5. That is going to be my middle. So I'm going to have a high at 9.9 and a low at 0.1. My vertical shift is going to be at 5. Now, we know that the high tide is at 9.9. That's at midnight. Okay. So then let me just mark that. So for this, we know that midnight is our high tide. And then 12 hours, exactly 12 hours later is our next high tide. What I'm going to do is I'm going to actually have midnight be the start of my graph, okay? And so I'm going to have this be midnight. And then 12 hours later, which is going to be 12 a.m., it will be my next high tide. Okay, so I'm going to have my y in axis be like midnight. That's going to be the start. So I'm going to have high tide, high tide. Halfway in between, which is going to be 6 a.m., is going to be the low tide, which is at 0.1. Then in between those, which would be 3 a.m. and 9 a.m., I am going to be at 5. And that's our graph. And then for this equation, I'm going to go y equal my a, or my amplitude, is the distance between those, which is going to be 4.5. This is a cosine graph, is how I would do it. Our period is 12 hours. And I know that period is equal to 2 pi over b. So I'm going to take 12 is equal to 2 pi over b, which means that I'm going to have b is equal to 2 pi over 12, or pi 6. So this is going to be pi 6. I'm going to have this be x because, again, I'm going to have this just be midnight as the start of this. And then we're going to go beyond that. And it was shifted up +5. I normally would not have midnight or something like that on the y-axis, but for this one, just so that we understand where my 12 a.m. is versus my midnight, I'm going to have that just starting on the y-axis. Okay, on our next problem, we are going to be graphing this. Y equal -3 cosine 2 times x minus pi force plus 4. My amplitude is 3. My vertical shift is a +4, a +4. My period is 2 pi divided by my b, and my b is 2, so it's pi. And then my phase shift is going to be pi force. So what that means is I'm going to start at pi force. I am going to go pi away. Now pi in terms of force would be 4 pi force. So I'm going to end up at 5 pi force. So when I have my graph, let me draw that, sorry. I am going to be starting up at 4. I'm going to go 3 below, which is going to be at 1. I'm going to go 3 above, which is going to be at 7. That's going to be my middle and my high and low. We're going to be starting at pi force. So that's 1, 2, 3, 4, 5. I'm ending at 5 pi force. This is cosine. It's a negative cosine. So I'm going to start at my low, end at my low. Halfway in between is my high. And then I have my zeros. And there's my graph. And I need to see the y-axis with the high, middle, low, and the x-axis with the start and stop of your cycle. Okay, on 15, the fifth term of this, okay? So what I'm going to do is I'm going to take 13, which is the power this binomial is being raised to, minus the term I want, which is 5. So that is going to give me 8. And then what I always do, let me do it this way. I always add 1, okay? I'm going to subtract them and then add 1. And so that's going to be 8 plus 1, I get 9. So I'm going to be doing 13 choose 9, something to the power 9, something to the power 4, because 9 plus 4 adds up to 13. Okay. Now I am going to take this and put it here. And I'm going to take this and put it here. So I am going to have 3x to the 4th here and 7y here. And then I'm going to work this out. So let me get my calculator. So I'm going to be doing 13, choose 9, okay? And that is going to be, let me just close that parenthesis. That is going to be multiplying with my 3 to the 9th. So 3 raised to the 9th. And that is going to be multiplying with, well, my y to the 7th doesn't have an exponent, so I guess I'm not multiplying anything. So I am going to get 14073,345. So I get 14,073,345. And then I'm going to have my x to the 4th raised to the power 9. Power to power I multiply, so it's going to be x to the 36. And then I'm going to do power to power here. So that's going to be y to the 28th. And that's what the 5th term would have been if we expanded this. Now, on the next one, we are going to expand this. So the very first thing I'm going to do is I'm going to do my Pascal's triangle. Let me just kind of start it above here, and let me just kind of, here, I'm going to use this side. I'll make this bigger so I've got some space. Okay, so I am going to be starting with 1, having a 1 and a 1. Next row is going to be 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. And this is going to be the row I want. 1, 5, 10, 10, 5, 1. That's what I'm going to use. So I am going to be taking my 3m I would really have a 1 in front, but I don't need that 1 in front. And this is going to be raised to the power 5. Now, my -2 would really be raised to the power 0, but I don't need to write that. Plus 5, and this time my 3m is going to be raised to the power 4, and that -2 is going to be raised to the power 1, because these are going to add to 5 each time. Okay, plus 10 times my 3m, this time to the third, and that means my -2 is going to be raised to the second, because again, these have to add to that 5. Plus 5 times 3m to the second, and that means my -2 is going to be raised to the third, because again, 2 plus 3 give us 5. And then I am going to have, oops, I needed 2 10s. I apologize. Okay, I had a 10 and a 10. Okay, so this should have been a 10. 10 and a 10. Okay. And then I'm going to have 5 times 3m to the first and -2 to the fourth adds to 5. And then I'm going to have plus -2 to the fifth. So now I'm going to work this out. So when I work this out, okay, I'm going to take 3 to the fifth, which is 243m to the fifth. Here, this is going to end up being a negative because it is going to alternate signs when you're doing a binomial with a minus. So I'm going to have a 5 times 3 to the fourth, which is an 81, okay, times a -2. So I get negative or minus 810m to the fourth plus, and so this time I'm going to have 10 times 3 to the third, which is 27, times -2 squared, which is 4. So I get 1080m to the third minus, and this time I am going to have 10 times 3 squared, which is 9, times -2 cubed, which is a -8. So I get a negative or minus 720m squared. Then let me shift this a little. When I'm doing the 5, I am going to have 5 times 3 times a -2 to the fourth, which is going to be a 16. So I'm going to get 240m. And then I'm going to have a -32. And that's going to be our answer in expanded form. 243m to the fifth minus 810m to the fourth plus 1080m cubed minus 720m squared plus 240m minus 32. Okay, so this next problem, Billy has a 48% chance of striking out the batter. Billy faces 15 hitters. What is the probability he strikes out exactly 7 out of 15? So I'm going to be doing 15 choose 7 times something to the 7th times something to the 8th, because 7 plus 8 give us the 15. Now, the chance of him striking somebody out is 0.48, which means the chance of him not striking somebody out is 0.52. And then we're going to put this into our calculator. So when I put this into my calculator, I'm going to be doing combination. Okay, so 15 choose 7 times 0.48 to the 7th times 0.52 to the 8th. And here you can see what I did. So I did my combination, my 0.48 to the 7th, my 0.52 to the 8th, and I got 0.20195, so 0.2020 basically. So this is going to equal 0.2020, or about 20.20%. And that's the end of this video. Hopefully this helps you out. But again, you want to be trying these problems and then using this as a reference when you get stuck, or to double check yourself.